We are on the LEQ, how do electrical charges react with one another? By the end of this video, you should be able to explain how an object becomes charged. That will be on your test. To help me explain how an object becomes charged, I want you to meet someone very special. His name is Chucky the Charge. Hi folks, I'm Chucky the Charge. I move through electrical circuits. My job is to carry electrical energy to the bulbs and other devices in the circuit. Did you know that there are two types of charges, positive and negative? So that means that Chucky could have a negative or a positive charge. Let's see how they react with one another. Do they like each other, or are they going to run away from each other? What do you think would happen if a positively charged Chucky comes close to a negatively charged Chucky? If you said attract, you are correct. Opposites attract, so the positive and the negatives get along very well and they really like each other. But what do you think would happen if two Chucky the Charges that were both charged negative and they were brought close together? What do you think would happen? If you said repel, you are correct. Charges that are the same don't like each other and they try to run away or repel from one another. So what do you think would happen if there were two Chucky the Charges that were both charged positively and brought close together? That's right. They run away from each other or repel. So how does an object become charged? Objects can become charged by moving the negative charges from one object and placing them on another object. Usually this is done by rubbing the one object across the other. The force of friction moves the negative charges from one of the objects and places them on the other. Negative charges are the only type of charge that can move. So let's see what that looks like in real life. Let's use the example of combing your hair. The first thing that needs to happen in order for an object to become charged is that the comb needs to rub through the hair. That friction will help cause the charges to move. So the very first thing that happens is friction. The comb is rubbing through the hair. Now, originally, the hair and the comb were both neutrally charged, meaning that they had the same number of positive and negative charges. However, when the comb rubbed through the hair, the negative charges moved from the hair to the comb. That means that the comb now has more negative than positive charges, so it makes it a negatively charged object. And the hair has more positive charges left, so that makes it a positively charged object. If an object gains the negative charges, its overall charge is negative. If the object loses negative charges, its overall charge is positive. Every material reacts differently, but there are certain materials that can be charged negatively very easily, and there's others that can be charged positive very easily. Let's use an example of wool on a balloon. First, friction needs to occur. The objects start off as neutral, however, negative charges are the only type that can move, so the negative charges move, and that leaves the wool being mostly positive, and the balloon is mostly negative. And what you would observe is that they would attract because positive and negatives attract. Let's watch the next couple of examples to see if we can determine which object becomes charged positive and which object becomes charged negative. Then try to decide what the charged object will do to a piece of paper that is not already charged or neutral. So here we have our balloon. As you can see, there are 5 positive charges and 5 negative charges. That means it is called neutral. And here we have a piece of wool that is also neutral because we have the same number of positive and negative charges. Watch what happens when we apply friction and rub these two objects together. Notice what type of charge is the only one that moves. In this case, the wool easily gave up its negative charges, leaving the wool to be more positive, the balloon to be more negative. Now let's see what would happen if we bring that negatively charged balloon towards this piece of paper. What do you think is going to happen? Okay, let's find out. Remember, like charges that are alike repel from one another. We have not rubbed the balloon on the paper, so there's no charges jumping. However, because we are bringing a negatively charged balloon close to the paper, the negative charges in the paper are going to repel as far away as they can on the paper. That leaves the left side of the paper to be more positive. And then that means that the balloon, which is negative, and that side of the paper, which is more positive, are going to attract. So you might observe, if you did this in real life, and some of you during the lab noticed this, that your paper was trying to stick to the balloon. I mentioned that some objects can give up their negative charges more easily than others. Let's look at what happens when we bring polyester near a balloon. Polyester is just another type of fabric. As you can see, both objects are neutrally charged. They both have the same number of positive and negative charges within itself. Apply a little friction. You'll notice that in this case, it's the polyester that steals away the negative charges because of the type of material that it is. It collects negative charges more easily than the rubber in the balloon. Let's bring that positively charged balloon near the paper. What do you think is going to happen this time? Remember, only negative charges can move, so let's observe what happens. In this case, we have a positive balloon, so the negatives in the paper are going to attract towards it. Remember, they're not going to jump ship because we have not rubbed the paper. However, they are going to move as close as they can to the balloon within the paper. And because the balloon is positive and the paper, that side of the paper is now negative, positives and negatives attract, so you would see the balloon would try to attract to the paper, or I should say the paper would try to attract to the balloon. We're going to take a break right there, and we'll come back to Chucky the Charge in a few days after we look at some circuits again.